This lesson is on prime and composite numbers. You will learn the difference between a prime number and a composite number. A prime number can be divided evenly only by 1 or itself. It must be greater than 1 and it must be a whole number. Here's an example. 7 can only be divided evenly by 1 or 7, so it's prime. If it's not prime, it's called a composite number. 6 is a composite number because it can be evenly divided by 1, 2, 3, and 6. So down here we have 2 is a prime number, but 4 is not a prime number because it's 2 times 2 will equal 4. The prime numbers only have 2 factors, 1 and itself, because 1 times 2 is 2. 1 and 3 are those factors for 3. There's no other way to get 3. Likewise, a composite number can be divided evenly by numbers other than 1. For example, 9. 9 can be evenly divided by 1 and 9, but also by 3. So we have prime numbers and composite numbers. The prime numbers only have 2 factors, and composite numbers have 3 or more. So we're going to write that out. Into our notes, prime number, only 2 factors, and the factors must be 1 and itself. Can you think of another prime number? Composite numbers is 3 or more factors. Now there is one number that's an exception, and that's the number 1. 1 is not prime or composite. It's our special number. We use it as every factor, or as a factor for every number. So we're going to search for the prime numbers and see what we can find. Every composite number can be written as a product of prime numbers. Around 300 BC, Euclid, who was a mathematician, was exploring prime numbers. He proved there was no largest prime. Another Greek mathematician, around 200 BC, used a simple strategy for finding the primes, and that's what we're going to do today. This strategy used the idea that any multiple of a number is divisible by that number. So take out your 100 chart, and we're going to start with this. First of all, because 1 is not a prime or composite number, draw a star on top of it. This reminds us that it's a special number. You can do that with a colored pencil. Now, with a different color pencil or marker, circle the 2. And then we're going to count by 2's, circling all multiples of 2. For example, here I'm going to put a star on number 1 because it is neither prime nor composite. I'm going to circle the 2 because I know 2 is prime. There are no factors except 1 times 2 to make 2. And then I'm going to count by 2, or do 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. These are all multiples of 2. And as I go, you can kind of see a pattern. And you're going to do that all the way down to 100. When you are finished with that, you're going to do number 3. Circle the 3 with a different colored marker or colored pencil and cross out every third number. So if we look at our chart, remember you have to go all the way to 100. I just didn't do it for time-wise. 3, and then 3 times 2 is 6, but it's already crossed out because it's a multiple of 2, so you don't have to really recross it out again. 3 times 3 is 9, so we cross that one out. 3 times 4 is 12, already crossed out. 3 times 5 is 15, and then we count 1, 2, 3. 18 is crossed out. 1, 2, 3, cross out 21, and so forth, all the way down to 100. So your chart will be completely filled when you're done, and we can skip 4. Do you know why? because you've already crossed out the multiples of 4 because of 2 times 2. Okay, we're going to continue in the same pattern, starting each time by circling the next number that's not crossed out. So the next one would be 5. It's not crossed out, so we do multiples of 5. Then we do 7 and multiples of 7. At some point, you're going to realize there are no more to cross out, and you should be done. Try to use a new color each time. The leftover numbers on your chart are the 25 prime numbers we will start to learn. You can refer to the chart during the lessons, but these will need to be known for the unit test. We'll go over these 25 numbers in class, so make sure you have them circled correctly on your chart. And that's a prime number and a composite number.